Dear students, welcome to the class of AE307 Signals and Systems. This class deals with the topic classification of signals. The different types of signals are continuous time and discrete time signals, deterministic and random signals, periodic and aperiodic signals, even and odd signals, energy and power signals, and the last one is that causal and non-causal signals. The continuous time signals, it is defined for all values of time t and is represented as x of t. It is also called analog signal. The figure 1 shows the continuous time signal or analog signal. Here the value is defined for all values of t or time. The discrete time signals defined at discrete instant of time t and is represented by x of n, where n is the index. We will get x of n, that is equal to x of n into capital T, which is equal to x of t, where small t is equal to n into capital T. The capital T is called the sampling period and n is an integer. The discrete time signal is shown in figure 2. The deterministic signals. The signal exhibiting no uncertainty of value at any given instant of time. It can be completely represented by mathematical expression. The examples are sine wave, cos wave, square wave, etc. The two deterministic signals are shown in figure 3. The random signals. In random signals, there must be uncertainty before its actual occurrence. It cannot be represented by mathematical equations. The pattern of such a signal is irregular. The examples of random signals are shown in figure 4. The periodic and aperiodic signals. The periodic signals, if we are considering the continuous time domain, the periodic signal is defined as x of t plus capital T, which is equal to x of t for all values of t. In discrete case, x of n plus capital N, that is equal to x of n for all values of n. The smallest value of t or capital N satisfy the above equation is known as fundamental period. The reciprocal of capital T is called the fundamental period. That is actually fundamental frequency, not fundamental period. The reciprocal of capital T is called the fundamental frequency. This is actually a typo. This is fundamental frequency. The aperiodic signals, in continuous case, x of t plus capital T, that is not equal to x of t. In discrete case, if x of n plus capital N, which is not equal to x of n, that is the case of aperiodic signal. The sum of two periodic signals, x1 of t and x2 of t with periods capital T1 and capital T2 may or may not be periodic depending on the relation between T1 and T2. If the sum of two signals to be periodic, then the ratio of periods T1 by T2 must be a rational number or ratio of two integers. Otherwise, the signal is not periodic. The next type, symmetric or even and anti-symmetric or odd signals. The symmetric signals, x of minus t, which is equal to x of t for all values of t. In discrete domain, x of minus n, that is equal to x of n for all values of n. The anti-symmetric signals, x of minus t, which is equal to minus x of t for all values of t, x of minus n, which is equal to minus x of n for all values of n in discrete cases. Any signal x of t can be represented as even component and odd component. That is x of t is equal to x e of t, which is the even component, plus x o of t, which is the odd component, where x e1 of t, which is equal to 1 by 2 into x of t plus x of minus t, and the odd component x o of t, which is equal to 1 by 2 into x of t minus x of minus t. Similarly, in discrete systems, x E1 of n, which is equal to 1 by 2 into x of n plus x of minus n, x O of n, that is equal to 1 by 2 into x of n minus x of minus n. The energy and power signals. Energy of a signal is defined as E, that is equal to limit t tending to infinity, integral minus t to t, the x of t the square dt joules. The average power is defined as P, limit t tending to infinity, 1 by 2t, integral minus infinity to minus t, integral minus t to capital T, modulus of x of t square dt, watt. For discrete time signals, E, that is equal to summation n from minus infinity to infinity, modulus of x of n square. The power value P, that is equal to limit n tending to infinity, 1 by 2n plus 1, summation n is equal to n from minus n to capital N, modulus of x of n square. A signal x of t is called an energy signal if its energy value should be in between 0 and infinity, which means it should be a finite value, and the power value should be 0. A signal x of t is called a power signal if the power value should be a finite value, which means it should be in between 0 and infinity, and the energy value should be equal to infinity. The causal and non-causal signals. A continuous time signal x of t is said to be causal if x of t is equal to 0 for t less than 0, otherwise the signal is non-causal. For an anti-causal signal, x of t is equal to 0 for t greater than 0. A discrete time signal x of n is said to be causal if x of n is equal to 0 for n less than 0, otherwise the signal is non-causal. For an anti-causal discrete time signal, x of n is equal to 0 for n greater than 0. Thank you.